Hi guys, so we keep exploring our organic chemistry. So in this video we're going to do alkanes, alkenes and alkynes. So first I told you that these alkanes, alkene and alkynes are going to be a families. So if a families, therefore all of them are the homologous series. So now we just have to understand how can you determine whether this compound is under alkane, this compound is under alkene, or this compound is under alkyne. And as I said, if your surname is Zenith, that means your full name is going to end with Zenith. If your surname is Neither, your full name is going to end with Neither. So if your full name is whatever, your full name is going to end with that. So if your surname is this and your name is John, so you are going to be John Zenith. If your surname is this and your name is John, your name is going to be John Neither. So it's because these are the families. So now we're going to do the same thing with these ones. So we have alkanes, alkenes and alkynes. So that means each and every compound that belongs to alkene or alkane, it's going to have a certain ending, and each compound that it belongs to alkene is going to have a certain ending. Compound that has alkyne is going to have a certain ending. So before we can learn about those endings, let's first define what's a saturated compound. So saturated compound is defined as any compound that has a single bonds between the elements. You see, so all of these compounds that have a single bonds in the elements are going to be a saturated compound. Okay, so let's start with here alkane. So since we said alkane is a family, so what's going to be the structure? So the structure, so that's going to be an identity. So identity falls under a functional group. So therefore, how do you know that this is under the family of alkane? So if you see something like this, let me just divide these things. If you see something like this, you see carbon. As I told you that carbon is going to have a 4 bonds. If you see something like this, just know it's under alkane. So it belongs to the family of alkane. If you see any compound that has only single bond, that means it belongs to the compound alkane. And this is the functional group of here. So this is going to be the functional group of alkane. And alkene, so alkene, how do you identify alkene? So alkene is identified of single bonds. So if you see something like this, so remember that we said that carbon, since it's in the 4th group, is going to have how many bonds? 4. 1 2 3 4 1 2 3 4. Okay, so if you see anything like this, that means it belongs to the family of alkenes. So let's explore the alkyne. So alkyne is like, if it's anything like this, that means it belongs to the family of alkyne. So that family is called homologous series, as I said. So if you see something like this and then they ask you what's a homologous series, it's alkene. Like this, alkyne, and like this, it's alkane. And then what we're going to put in here, in these spaces here, what are we going to put there? So since here we said that organic chemist is a chemist of all compounds that contain carbon. So therefore all of these are going to call hydrocarbons. So hydrocarbons. So hydrocarbons is going to be the functional group name, not structure. Get me right there. It's going to be the functional group name. So the functional group name is hydrocarbons. Why? Because all of these compounds are built using hydrogen and carbon only. So these compounds are built using hydrogen and carbon only. So therefore the functional group name it's called hydrocarbon, but the functional group structures are not the same. The functional group structure for this is this one, for this one is this one, and for this one is that one. Okay, so what are we going to fill on those space? So since we said that this is hydrocarbon, that means each and every element or compound is built using hydrogen and compound. So here we can fill hydrogen, 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 and hydrogen. Same as this one. You do the same thing. You do the same thing. You do the same thing. And be careful. Never do this. Never do this. Never say C. So C, since because it's alkene, it must have a double bond, and you do this. Be careful. This doesn't exist. This doesn't exist. Why? Because hydrogen can donate one. So if you do this, you are saying that hydrogen can donate two. And as I told you in my previous video, that will never ever happen in this world. Okay, so in our next video, I'm just going to show you how we name these things.